Okay, cool. So I'm Ronny, and I want to talk with you about classifying data. So building traditional classifiers is often pretty hard because you need large labeled data sets. And I would propose you another way where we can avoid the labeled training sets. So what we're going to do is I want to show you the core techniques in the playground, and afterwards we'll have a look to an application where we actually run this in production. Good, so let's get started here. So what I prepared is a little bit of data. I guess it's hard to see, right? Oh wait, that's also hard to see. But I will read it out, I guess. Maybe we do it like this. Okay, so we have a little bit of sample data here, which is customer feedback for the Spotify app, right? So the first one says the user value offline song downloads. The second one is user is frustrated with missing album art. And the last one is the user wants more language options on Spotify. So that's the data that we want to classify. And then we have simple prompt for this where we say classify all customer feedback into one of these categories. And we have feature requests, product issues, and positive feedback. And then we ask to get this back in a JSON format. So if you run this, you see it actually does pretty well. So the first one, which was our download, right? That was positive product feedback, and then the next one was a product issue with the album art, right? So we get the right things back. But if you look to this, I think you can maybe spot a couple of issues here. So first of all, it's kind of slow. It takes 1.5 seconds. It uses a lot of tokens. So one of the simple things that we can do here is we can cut down on all the structure. Sorry, just stick with me. So we can ask instead of an array, we could, for example, just ask back for a map. So now you see there's already considerable less tokens that we use up there. Should also get a little bit faster. But we can do better, right? So for example, we know it's only a handful of categories anyways, so there's no point of spelling this out over and over. So another thing that we can do here is we can say, instead of getting feature requests back, we just get R back, get I back, we get F back, and we don't want to have the whole categories, but just the shortcuts. So if we do this, things start to get a bit more compact on the right side. Now, one thing that we still have is, of course, the IDs here, and we have these UUIDs that allow us to express, billions of different things. But we know with the token limits, we can never put more than a couple of 100 data points into the LLM anyways. So what we can do here is, we can translate already before in our application this, for example, into a counter. And then when we get the result back, we translate it back into our internal IDs. And so what you can see now is here is way more compact representation of the output. So from the testing we did, it normally speeds it up by factor 2-3 approximately, and the amount of tokens normally goes down by 80% if you do this simple optimization. Now you might say that's an interesting idea to use the LLMs for classification. Does it work in reality, in the real world? And so I can say, yes, it does. So this is our application where we actually use this. So we convert customer calls into product insights. So, that might be support calls, sales calls, user testing, those kind of things. And we take out like 30-second clips, which are, basically feedback on the product. So we can see here, for example, these clips. And so here, these blue labels, that's exactly the classifications we just saw before. Like, for example, here we have, product feedback, and there we have, for example, a pain point. Now, the cool thing is that we now created kind of structured data out of our formerly unstructured data, which means we can, for example, push it into a dashboard. So now we can see here we have like 2,000 of these video clips, and we can see, 30% of them are, for example, pain points. Now, 30% of 2,000 is still quite a big number, so you can't put this in front of a user just to read through. So what we're doing then additionally is that we aggregate them. So, for example, a lot of people are frustrated with the ads on Spotify. But it has the same issue. So now we know what the cluster is, but which items are actually part of the cluster, which again is a classification problem. And so here we use the same approach, and I think you can also see more where the upside of this approach is, where we had before kind of fixed categories. So we knew beforehand this could be like a feature request or a product positive feedback item. Now, these categories are actually dynamic, right? So this can be different from customer to customer, but there might be also new classes created, they might be changing, and so on and so forth. And in none of these situations do you have to retrain any models, but you can just plug the data in and it will classify you the data. Good, that's what I wanted to share with you. If you want to try it out, you can go to nextstep.co, you can sign up there and try it out. And I guess we still have some time for some questions.
How do you go about creating those subcategories, like the frustrated with ads?
Okay, good. So since I had 5 minutes, I skipped this topic. So the way we create them is, so we take the data that is basically the clips, and then we do summarization of them. Now, of course, it's a lot of data, so then you go into batching and sampling, and that's the two main mechanisms we use for that.
Got it. Thanks.
It was very similar to the question that he asked, but so what I find with this kind of mechanism is that creating these kind of topics, so it's more like a topic modeling, right? It's kind of difficult to kind of cluster them and ask the LLMs to create these topics by itself. Do you kind of have a seed for having like a topic, or do you have like a method in which you limit the type of topics?
Yeah, sure. I can reflect on a couple of these things. So one of the things that we learned is having more homogeneous input data definitely helps a lot, right? And so we can use, again, these classifications that I showed you in the beginning. And if we say, create us classes around feature requests, and we only give feature requests, the quality is way better than if you just give whatever you have. I think the other challenge is that you want to have the output to be more homogeneous. Right? So you want to avoid having one thing is, I don't know, the button should be 5 pixels to the right. Another one, the UX sucks, redo everything, right? So it's just totally different granularity, and that's not really helpful. So we found that giving examples works pretty well of steering it into the right direction. And I think the same holds also for, basically how the output is written, where you also want to have that's more homogeneous. Again, I think we found examples to be the best way of steering towards more similar clusters.
Thanks a lot for presentation. Super cool to see the classification use cases. I was wondering, how do you do evaluations, especially if you consider different models and different frameworks for the same use case? Maybe like a smaller model would work more efficiently for specific cluster of classification problem.
So we use here, so this was OpenAI, what I showed you for our customers. So we work mainly for enterprise customers. So it's mainly OpenAI and then Azure. That's the one thing they all love if it's in the EU. You could use whatever model, I think, for this thing. So we stick with OpenAI mainly for quality, and it's the easiest to be acceptable by our customers.
An evaluation part, so for example, you can use different GPT 3.5, and I don't know, there are also deterministic models like semantic router. If you've tried it, would be just curious. So maybe to the evaluation part of it, so that's certainly one problem, right? And I think one of the issues that you're seeing is even if you put the temperature, if you control for this, still the output is actually quite different, right? So it's not like that you give the same input and you get the same output back. So this might go, I don't know, by a factor 2, the difference on, for example, the things that we find. So what we are doing is, so we run like regression tests on them that have a certain variance window, and if it goes out of the variance window, somebody is looking into this. And of course, if we update, for example, the models, so we change the models, then we run beforehand these tests and see what's coming out.
Thank you for your presentation. I was wondering, you do video, you transcribe the video, I guess, and then do you put the whole video into the prompt, or do you chunk it in some way, or do you do any chunking?
So what you saw before these highlights, right? That's basically parts of the videos, because the problem you have with the videos is there is a lot of people talking about how they ended up in the meeting. That's not really interesting, right? And so we basically produce these highlights that kind of aggregated nuggets of data of them, and they become the representation of the videos. And
so I guess the highlights are the chunks, sort of like.
Yeah, kind of. Yeah.
So can you tell something about how those highlights are created then?
So this is like a pipeline where we run this through, and just on a high level, it's the first step is typically you find out what's the topics in this video, for example, or can also be text. And then afterwards, we are looking for examples, quotes in these videos that are reflecting this. And then you mix it up with do you want to have these videos to be nice to view, for example? So that's one thing, so they shouldn't be too short, and so on and so forth. So there is then these other aspects that we are mixing into this.
Cool, thank you.
I have a question about your dynamic tags. I want to know when you generate two tags that are meant to be the same thing, but it generates the name slightly differently. How do you sort of collect them together?
So that's a really good question, and it's it's not a totally trivial problem, right? Because you might have your initial set, and how do you incrementally create new ones? And I think we have now a mixture. It works a bit, and from time to time you have to actually recompute them and then see and suggest to merge them, for example. So one of the things that we're doing is when we incrementally create them, that we provide the existing ones. But of course, then you also steer in this direction. So far, in our space, for example, we try to create them pretty early on so that new users, they discover the feature. But the problem is if they then upload 100 times the amount of data, they might not fit any longer. So then at that point, we might recreate them from scratch.
That seemed tricky, so I wanted to ask.
Yeah.
I'm curious how you measure your own quality. So when the user comes here and check the topics or check the quality and so on, how do you know you're doing well?
So we're using a couple of things. So one is, and that goes a bit back to the regression testing, where we do have actually also manually labeled data if you want. And we're checking new generations of models, or also our own stuff, how does it compare to this? Of course, you can't just compare it's the same, but then we're using, again, LLMs to find out, do we, for example, cover all the topics that are supposed to be found there? So I would say that's probably one part. Then the other thing what we're doing is, so basically we give this to the user, but what the users are doing with this is they share this then within the organization, right? So they might bring it to the developers, to the designers, the marketing people, right? And so for this, we track if people are watching this stuff and if they share it again, and that's also an indication. Now, of course, that can also was just a crap thing to start with. We did the best out of it, and therefore it wasn't, but at least it gives some kind of indication.
Just a very quick one. I'm curious if you can segment by product features of the customers, right? I have Spotify, for example, so it's like podcast versus, I don't know, videos or whatever, right? And the second is, I would love to see where some type of customers are complaining about these kind of problems. I'm wondering if you're thinking about that and what's coming next.
So for the first one, right, where you're looking for product areas, so that's actually one thing we do nearly for every customer. But one thing we actually learned is that LMs are really overkill for this in most cases and just go all over the place. Because in most cases, the users are literally talking about the thing, right? So often if you just do normal search, it's much faster, much cheaper, and often way more precise than using LLMs for that. And then the second one was breaking it
based on customer segments.
Yeah, exactly. So basically what we have here is, so basically you can split the data, so we have more metadata around them. So for example, we have them annotated from which accounts this video came. And then for the accounts, you might know, I don't know, whatever it is, your CIM, the geography or the industries or whatever. And then when we show, for example, the dashboards or you browse for the data, you can use, again, these dimensions to split off the data.
All right. Thank you so much, Ronny. That was really great. And also great questions. Thank you, everyone. This is why we want to keep demos at 5 minutes, so then there is more time for questions. We want the community to actually drive what is explained. So, yeah, that was really great. Thank you.